Hi, and welcome back to Network Security Lab Series, Lab 9, Intrusion Detection using SNART Walkthrough for Lesson 2, Setting Up the Sniffer. Passwords help to secure systems running remote operating system. If an attacker is able to get the administrator password on a remote system, they will be able to take complete control of that device. Companies need to have mechanism in place to protect systems connected to the internet from being exploited by remote attackers. Lesson 2.1 Logging on to the Sniffer. The Linux distribution Backtrack is installed on the Sniffer machine. Backtrack is a distribution used by security professionals for penetrating testing and forensics. Step 1, we're going to click on the Windows 2008 Server Sniffer icon on the topology. That will be here in the middle. You're going to see it, a blue icon looking like a PC. Click on that. That should open up your Windows 2008 Sniffer virtual machine. I've already logged in, but if you haven't, please go through the rest of the steps of 1 and 2. I'm starting at step 3, where we're going to click on the Start button. Then click on the right arrow and select Restart. Then we're going to select the option Hardware Maintenance Plan in the list from the drop-down box and click OK. That's going to start us back at this Backtrack 4 screen, where we're going to select the second choice of the menu and press Enter to boot into the Linux, and you will need to use the down arrow on your keyboard to navigate to that second choice and hit Enter. When it starts back up, we're going to need to type the following command to initiate the GUI, Graphical User Interface. And we'll be typing in Start X, as you can see here in the screenshot they provided us below on our documentation. Next, we're going to adjust our screen as it logs in. We're going to click the small blue arrow at the bottom right corner of the screen to adjust the resolution. And we're going to select the 1024 by 768. And we're going to accept the configuration when you get this pop-up for Confirm Display Setting Change. On step 8, we're going to open the terminal on the Linux Sniffer system by clicking on the image to the right of Firefox in the taskbar in the bottom of the screen. One of the nice features of some versions of Backtrack is that they are not automatically assigned IP addresses through the use of Dynamic Host Configuration Protocol, DHCP. This is because the interfaces are not active. They must be manually enabled. The idea is to come on the network quietly without being detected. And in step 9, only the loopback address 127.0.0.1 is displayed when you type ifconfig. So we're going to start with that. We're going to type in ifconfig and hit enter. Now, as you can see, you should only be able to see the IP address of the loopback address, and it says here up on the top, local loopback address. Next, on step 10, we're going to type the following command to view all available interfaces on the system, which is ifconfig. But this time we're going to do a space -A and hit enter. And now we can see all the available interfaces. We have ETH0, ETH1, and LO, which stands for the loopback. Neither of the interfaces, ETH0 or ETH1, is assigned an IP address on their respective networks. The reason the Sniffer has two interfaces is that it is located on two networks, the internal network, LAN, and the external network, WAN. The 2008 firewall also has two interfaces and also is connected to both networks, as you can see in the diagram that they provided below. Network 1 up on the top is the internal network, and network 2 is the external network. And you can see that the firewall and the sniffer are between both networks. A sniffer should be operating in promiscuous mode so it can see all network traffic. Two ways to ensure that a sniffer will capture all traffic on a network segment are connect the sniffer and other devices on the network to a hub, and connect the sniffer to a switches span switched port analyzer port. To put interfaces into promiscuous mode, type the following commands. Step 11. To activate the first interface, type the following command: ifconfig eth0 up. So back at our terminal, we're going to type just as it is written, ifconfig space eth0 space up, and it's all lowercase, and hit enter. Now, to verify the first interface, type the following command: ifconfig space eth0 and hit enter. Now, you're going to verify that the status of up is shown on the second line of output here. This is eth0, and on that second line, it says up. To activate the second interface, type the following command. So back at the terminal at the bottom, we're going to type in ifconfig, all lowercase, space eth1 space up, and we're going to hit enter. And now we're going to verify that second interface by typing in the following command, which is ifconfig space eth1. And again, we're going to double check to see if eth1, like eth0, has up on that second line there. The Linux Unix utility tcdump is commonly used by network administrators to capture network traffic on a sniffer. Many sniffer machines do not have a graphical user interface, so running GUI-based tools like Wireshark or Network Miner is not possible. Another benefit to using tcpdump is that it handles very large capture files well. Wireshark loads files into RAM, so if the file is too large, it might not open. So now we're going to type the following command to view several available switches for tcdump. We're going to type in tcpdump space -- help. And this will give us a listing of the available switches for tcpdump. Now, to run tcpdump on the network segment interface eth0 is connected to type tcpdump space -i, as I is for interface, space eth0, because that is the interface we want to look at. Hit enter. Wait until at least one IPv4 packet is displayed before stopping the capture. It could take a couple of minutes before a packet shows up. So we're going to wait here a little bit, and hopefully it'll start loading up. For me, as you can see for me, several IP packets have came in. It says, next it says, after one IPv packet or more is displayed, press Control-C on your keyboard to stop the network capture. So I'm going to press those. And you can see 5 packets captured, 5 packets received by filler, 0 packets dropped by kernel. If the network 192.168.1.1 WAC 24 is displayed, ET80 is located on the first internal network. If the network 216.0.0.0 WAC 24 is displayed, ET80 is located on the second external network. Also notice that the default for the TCP dump is to capture only the first 96 bytes. The -S0 switch will allow TC dump to capture the full packet size of 65,536. Now, to run TCP dump on the network segment interface ETH1 is connected to, type TCP dump -I ETH1-S0. Wait until at least one packet is displayed before stopping the capture, and then log onto the Windows 7 machine as student with the password of password if you do not see traffic. Okay, as you can see, a couple of packets had came in for me. It says after one packet or more is displayed, press Ctrl+C to stop the network capture. If the network 192.168.1.0 WAC 24 is displayed, ETH1 is located on the first internal network. If the network 216.0.0.0 WAC 8 is displayed, ETH1 is located on the second external network. The -S0 switch is used to capture the full packet size, which is 65,536. Now, to capture traffic on the 192.168.1.0 WAC 24 network and send it to a file type, you have to type in the following: TCP dump space -I space ETH0 space -NNTTTT space -S space 0 space -W space capnet1.pcap space -C space 100, and I'm going to double check if I typed everything in correctly. Oh, that dash is supposed to be a 0. Okay, and hit enter. Be sure to enter the appropriate interface in the command syntax. I'm going to pause the video here, and we're going to come back to a part 2 of this. So keep everything logged in and just start up our next video.